Hey guys, today we're learning 10.6, which is on circles again. So yesterday we did area of circles and sectors and segments, and today we're doing circumference, which means that we're focusing on the outside of the circle. We're going to learn about arcs and arc measures and arc lengths. So first thing to talk about is, what is an arc? An arc is a part of the circle. So it's all the points on the outside essentially. One type of arc is a semicircle, and that's half the circle. So in the figure that I have, it would be from R to T, either direction, because it's the same distance to go from R to T as it is to go on on top as it is to go around bottom. A minor arc is smaller than a semicircle, and a major arc is larger than a semicircle. And the way we name them is important. So we name a minor arc by using just its endpoints. So if I have a minor arc like RS, you just take the shortest distance, go directly from R to S. Same thing if I was going from like T to S. If I said TS, even though maybe you would think to go around like a clock like this way, instead we always go, if it's just 2 points, it's endpoints, and we just go the shortest distance, TS, that way. Now, if we name a semicircle or a major arc, we need to use 3 points. We need to use 3 letters in order to name that. You use its 2 endpoints and then another point that's somewhere in between those 2 endpoints. That kind of tells you the direction that you're going. So the example I have is STR. So if I'm going from S, the major arc STR, you start at S and then you go through T and then you go all the way to R, and we see that that is bigger than a semicircle. It is a larger arc. It is a major arc. So when we name a semicircle and a major arc, you need 3 letters there. Okay, arc measure. We kind of touched on this last lesson, but I didn't go too far in depth. The measure of a minor arc is equal to the measure of its corresponding central angle. So if you have an angle on the inside like this 50 degrees, then that means that the arc measure from R to T is also 50 degrees. It's in the same units, it's the same degree. However, the measure of a major arc is the measure of the related minor arc subtracted from 360. So if I know RT is 50, to go from RQT, I'm just taking 360 minus 50, and that's how I got 310 right there. So you think of going the entire length around the circle, but we're not doing this little part that's orange, we're just doing the blue part. And the measure of a semicircle is 180, because it's half of the circle, it's half of the measure. Divide 360 by 2, you get 180. Okay, so let's do an example. So I've got a picture over there to the left. AC and BD are diameters of this circle O. That's what that circle with the dot in the middle means, circle. We want to find the measure of each arc. So, and then we're going to identify each arc as a major arc, minor arc, or semicircle. So I have right here, angle AOB is 44. Well, if AOB is 44, then so is arc measure AB. So this distance is also 44 degrees. So I'm going to write that here. I'm going to write that as 44 degrees. We're going to come back and label major, minor, and semi. I think that would be easier that way. Okay, now I'm going to do DA. So I'm going the distance from D to A. Again, since it's just 2 points, you just go the shortest distance this way. If I know that BD is the diameter, then I know that the entire distance from B to D would be 180. How much would it be from A to D, or D to A? Good, minus off 180, because we've got essentially a linear pair here. So we're going to do 180 minus 44, and that's going to give me 136. 136 degrees is AD. And I'm actually going to mark that on my picture so I don't forget that for the future. 136. Okay, now I'm going to do BCD. I'm going this time B to C to D. What do we know about BD again? Right, it's a diameter. So if it's a diameter, it makes a semicircle from BCD, from B to C to D. That's a semicircle, and we know the measure of a semicircle is 180. Very good. Now I've got BC, So I don't want the whole distance BCD, I just want the distance now from B to C. Do you remember what we call these angles right here? AOD and BOC? That's right, vertical angles. And vertical angles are congruent. Yep, we never leave chapter 1. It always comes back. So the measure of AD and BC are congruent. This is also 136, and I don't have to do any math out because I already did the math. The last angle that we need to find, or the last arc measure, excuse me, is ACB. So I'm going to go from A to C to B. That is almost the entire circle except for this little 44 degrees right here. So we can do this two ways. I think the easiest way to think about it is doing 360 minus 44. But another thing we could do is add up all the lengths that come with it. 136, what would OD be? 44, good. And then what was BC again? Right, 136. So we could do 136 plus 44 plus 136. Those two answers are going to be the same, and if you throw it in your calculator or if you've got some awesome mental math, that gives you 316 degrees. Okay, let's go back and label these as major, minor, or semi. Well, we know semi is a 180. We know anything smaller than semi is a minor, and we know everything bigger than semi is major. So AB is minor, good. DA is good. It seems big, but it's also a minor, less than 180. What about BC? Well, it's the same as DA, so it's also minor. And then last, ACB, that's bigger than my 180, so that is my only major. All right, keep rolling. We just did this without having known the postulate. This is just kind of like an oh duh postulate, I like to call. This is about adjacent arcs. So they're arcs that are next to each other. They are in the same circle and they have one point in common. So like AB and BC are adjacent because they share the point B. You can add the measures of adjacent arcs just like we add the measure of adjacent angles. So we learned that again back in chapter 1. When we have two angles next to each other, we could do angle addition. Same thing here. We can do arc addition. Add the two arcs if they're next to each other. Moving on. Okay, now we're on this back side of your notes. Circumference of a circle. I know that you know this, but just a little reminder. The circumference of a circle is pi times the diameter or 2 pi times the radius. Whichever one works for you is fine. I just like to use whatever is given to me. So if it's given to me radius, I'm going to use the radius one. If it's given to me diameter, I'm going to use the diameter one. I don't want to work any harder than I have to. So first example, we're going to find the exact circumference, which means that I want all of my answers left with pi. Don't give me any decimals. Okay, so I have to find the exact circumference of this shape. In the first circle, it's inside of a box. It's inside of a big square, and the distance from one point of the square to the other is 11. I can kind of think about moving this distance into the inside of my circle, and that distance is also going to be 11. From the top of the shape to the bottom of the shape is also 11. We know that that's my diameter, so if diameter is 11, I can think of circumference as pi times diameter, which is 11. Since I want this exact, the best answer is 11 pi. Don't forget your units. Yards. All right, next one. Now I have a triangle on the inside. I do have a diameter drawn. How do I find out this distance? I've got a right triangle. I have two sides given to me. How do you find the third side? Yep, Pythagorean theorem. 5 squared plus 12 squared equals d squared. Again, nothing ever goes away. 5 squared is 25, 12 squared is 144, equals d squared. When you add those together, you get 169 equals d squared. So when I take the square root of both sides, d is going to equal 13. So my diameter is 13. So circumference is pi times diameter, or pi times 13. Best answer is 13 pi centimeters. All right, and then last example on this slide, I've got a big shape. Again, I see my diameter. How do I find its distance? I've got another triangle. You could do Pythagorean theorem, but we know an easier way. We know special right triangles. This is a 90-degree angle, and since these radiuses are the same, these radii are both congruent to each other, we have a 45, 45, 90. How do you get from one leg to the hypotenuse in a 45, 45, 90? Multiply by root 2. Root 2 times root 2 is root 4, or just normal 2. So circumference is going to equal pi times diameter, which is 2. Circumference equals 2 pi centimeters. Awesome. Okay, now we're talking about the arc and its length. So we talked about arc measure, which is always in degrees. For length, though, length is part of the circumference of the circle. And this is a lot like what we just did yesterday with our area of a sector. The sector relates to the circle like the arc relates to the circle. It's a fraction of the circle. So we're going to do the fraction of the circle times the circumference. The arc length is like a fourth or a half or an eighth or 5/7 of the circle. So we have to figure out what fraction it is and times it by the circumference. To find out its fraction, we're going to do the angle, the central angle, AOB, divided by 360, and multiply that by our circumference, which is either pi d or 2 pi r. Put a little or in there. All right, let's do an example. Actually, we're doing two. I know I have one picture right here, but we're going to do the first example if the radius is 2 meters, and then we're going to do the second example, same picture, if the diameter is 7 inches. Okay, so just same picture, two different examples. Okay, so we need to find DE if the radius is 2 meters. So I have to find this arc length, DE, if my radius, the distance from a point on the circle to the center, is 2. So I need to use my formula. I need to use the central angle measure divided by 360 times my circumference. My central angle measure is 120, so I'm going to do 120 divided by 360 times my circumference. Pi, either diameter or 2 pi r. And I'm going to do 2 pi r because I'm given pi, r. 2 pi times r, which is 2. All right, if I simplify 120 and 360, that leaves me with 1 over 3. So I've got 1 over 3 times 2 times pi times 2, which is 4 pi. Again, I want examples exact and simplified. I cannot divide 4 by 3 evenly, so I'm going to leave it as a fraction. 4 over 3 pi. And what's my units? Meters. Okay. Now I'm going to do the second example looking at the same first picture. I'm going to do DEA. So I'm doing this distance all the way here, from D to E to A, all the way. So now my central angle is not 120, it's going to be 120 plus 90. 120 plus 90 is 210. So I'm going to do 210 over 360 times my circumference, which is going to be pi times d. D this time is 7, so I'm going to do pi times 7. Sorry, I didn't use parentheses earlier. I don't know why I'm doing it now. I'll just do times pi times 7. I hope that looks more familiar. So 210 and 360, I'm going to simplify that. That becomes 7 over 12. Ugly fraction, but we can handle it. 7 over 12 times 7 times pi is just 7 pi. Again, I want it exact. Don't throw this in the calculator. Do not give me a decimal. Leave it as a fraction. This is the same thing as 7 pi over 1, so I'm left with 49 over 12 pi. And then don't forget my units, inches. All right, that's it. Again, if you need help, rewatch the video, let me know. Good luck on the homework. I'll see you later.